French submarine development began in the mid-19th century. These were pioneering experiments in creating mechanized underwater vessels, marking the transition from human muscle power to more reliable solutions for the Navy. In 1863, the submarine plongeur was launched. It was the first submarine in the world powered by mechanical energy rather than human strength. It used compressed air engines for limited submerged movement and became France's first attempt to apply underwater technologies in naval warfare. Following that, in 1888 came Gymnote, the first fully electric submarine. It showed better handling and submerged endurance thanks to its battery power. This proved the effectiveness of electric systems for stealth operations and influenced all subsequent designs. At the beginning of the 20th century, France built many experimental and combat submarines. Among them were the Sirene class of 1901 and the Emeraude class, built between 1906 and 1908. They were equipped with self-propelled Whitehead torpedoes and were intended for coastal defense. This is how 19th century prototypes turned into a structured program under the leadership of naval designers Gabriel Maugus and Maxime Leboeuf. International achievements significantly influenced the creation of French submarines. Designers drew inspiration from global innovations to make their submarines faster and give them better endurance. For example, John Holland's American submarines, with their electric propulsion, stability, and torpedo armament, had a major indirect impact on European programs. The British began building their A-class submarines in 1900, inspired precisely by Holland's designs. This happened after they observed the maneuvers of French submarines and realized they could pose a threat to the surface fleet. At the same time, France began improving its own prototypes to gain that same tactical advantage. German U-boat predecessors, focused on creating large ocean-going vessels, also pushed Europe into competition. French designers, however, placed their bets on diesel-electric hybrids. This was a new technology that allowed them to increase surface range while remaining stealthy when submerged. Thanks to these foreign influences, by 1914, France had produced 55 submarines. This made its navy a leader in underwater experiments, although globally it dropped to 5th place because the budget was primarily directed toward ground forces. France's strategic interest in submarines at the turn of the 20th century was driven by geopolitical pressure. The country needed to protect its vast colonies and challenge Britain and Germany at sea. The Fashoda incident of 1898 nearly led to a war with Britain over African territories. It exposed the vulnerability of sea routes and gave a push to submarine trials. These tests showed that submarines could challenge stronger surface fleets near the coasts, becoming a cost-effective way to defend ports and colonial bases. Rivalry with the German high seas fleet also stimulated investment. Submarines provided an asymmetric advantage, allowing them to counter German battleships without needing to build an equally massive surface fleet. The Anglo-French Agreement of 1904 resolved colonial disputes and shifted priorities. France was able to concentrate its submarine and surface forces in the Mediterranean Sea to defend against potential threats from Italy and Austria, relying on British dominance in the North Sea. In this way, submarines became an essential part of a large-scale defense strategy. The vessel that would eventually be named Mariotte reflected the French Navy's practice of honoring figures associated with science and engineering. She was named for Edmé Mariotte, a 17th century French physicist known for his work on the relationship between pressure and gas volume. The choice was particularly fitting for a submarine, as its operation relied on controlling compressed air, ballast, and pressure within a sealed hull. Because she was an experimental prototype, not the first of a production class, nearly every phase of her career was treated as a practical test to see if a fast, sea-going submarine could operate alongside a battle squadron, rather than being limited to coastal defense. The design process for the French submarine Mariotte began with a competition organized by the Ministry of the Navy in 1906 as part of the 1905 to 1907 Naval Construction Program. The objective was to develop an experimental prototype with improved surface capabilities to accompany the fleet. This initiative aimed for innovative solutions to push submarine technology beyond existing classes like the Brumaire and Pluviose. The winning proposal came from engineer Charles Radiguier. His design emphasized a streamlined single-hull configuration to optimize hydrodynamic performance and speed. This built upon the single-hull design seen in the Emeraude class, which was common in several earlier experimental designs. The competition's requirements were unusually demanding for the time. The proposed submarine was expected to displace around 530 tons, achieve a surface speed fast enough to keep pace with a battleship squadron, and travel approximately 100 nautical miles while submerged. These goals pulled the design in opposing directions. A larger battery would increase underwater endurance but add weight, while a fuller hull would provide more reserve buoyancy but create greater resistance. Radiguier therefore opted for a long and exceptionally narrow hull with only moderate reserve buoyancy. He also raised the forward deck into a prominent forecastle while keeping the aft portion of the hull very low in the water. In profile, the high bow and nearly submerged stern gave it an unmistakable outline that earned Mariotte the nickname brosse à dents, or toothbrush. Maxime Leboeuf, a pioneering French naval engineer, made significant contributions to the integration of diesel propulsion in submarines during this period. This included a 1906 mission to Germany to evaluate advanced diesel technologies, which influenced the power systems for prototypes like Mariotte. Radiguier further developed these advancements by specifying Sauter-Harl 6-cylinder, 4-stroke diesel engines paired with electric motors. This system produced 1,400 horsepower when surfaced and 1,000 horsepower when submerged. This setup addressed key compromises by prioritizing a high surface speed of over 14 knots for tactical integration with surface fleets, while maintaining an adequate submerged speed of around 12 knots. However, it necessitated sacrifices in battery capacity and fuel storage compared to slower submarines designed for endurance. Initial specifications outlined in 1907 envisioned a surface displacement of 522 tons, a length of 216 feet, and a single hull structure to balance speed and maneuverability. The designers favored a streamlined shape over the added volume of double hull configurations for better performance in rough seas during surface operations. These choices reflected careful engineering decisions to enhance overall versatility, though early plans anticipated adjustments for buoyancy and stability based on projected trials. Mariotte was one of 4 experimental submarines ordered between 1909 and 1912, alongside Archimedes, Amiral Bourgeois, and Watt, to test advanced configurations for fleet modernization. The unusual hull shape was not just for looks. The raised bow helped the submarine stay dry while running on the surface in rough seas, and the fine underwater lines reduced water resistance at high speeds. But this design choice had its drawbacks. The reserve buoyancy turned out to be too small for a boat that had to spend extended periods on the surface. It later became clear that its stability and buoyancy did not meet the Navy's expectations. During construction, the actual displacement exceeded initial calculations. Surface displacement was about 545 tons, and submerged displacement was 634 tons. This clearly shows how new engines, batteries, and armament gradually ate up the available space in the experimental project. The French submarine Mariotte featured a single hull structure. For its time, this was a true innovation, combining strength and excellent hydrodynamics. The boat had a length of 212 feet, a beam of 14 feet, and a draft of about 13 feet. Surface displacement was 531 tons, and submerged displacement was 628 tons. Thanks to its streamlined shape, Mariotte could escort the main fleet, although the crew had to handle ballast very carefully to maintain stability. Propulsion was provided by an advanced diesel-electric plant. It consisted of 2 6-cylinder Sauter-Harl diesel engines producing 700 horsepower each. On the surface, they drove 2 propeller shafts and brought the boat to a surfaced speed of 14.2 knots. Submerged, these same shafts were driven by 2 electric motors. They drew power from batteries that were charged on the surface, allowing a submerged speed of 11.7 knots. For the early 20th century, this was a massive step forward in submarine endurance. Each diesel engine turned a propeller over 5.5 feet in diameter. Submerged, propulsion came from two Breguet electric motors producing 500 horsepower each. Power was stored in two battery banks consisting of 124 cells. This equipment made Mariotte's performance unique among French submarines of that generation. The vessel had a respectable surface speed and could run submerged at a speed of 11.7 knots. This submerged figure was simply staggering. At the time, it was an absolute record for the French Navy, which, according to historians, remained unbeaten for about 35 years. Surface range was 1,658 nautical miles at a speed of 10 knots. Submerged, the boat could cover 143 nautical miles at 5 knots. But these numbers also reveal the main weakness of early diesel-electric submarines. High submerged speed could only be sustained for a very short time, as it drained the batteries much faster than economical cruising. The maximum safe diving depth was 115 feet. Thanks to an efficient ballast system, the boat could quickly escape a threat, with diving taking only 2 minutes. Another major design choice was moving most of the buoyancy tanks to the bow. This improved the submarine's handling in rough seas and solved the stability issues found during initial sea trials. Shifting the center of buoyancy forward like this helped maintain the compact single-hull design. The main armament of the French submarine Mariotte consisted of 4 17.7-inch forward torpedo tubes. This allowed the boat to carry 8 torpedoes. In addition, the submarine was equipped with 2 external Drevesky drop collars. These could launch extra torpedoes housed outside the pressure hull. Unlike many designs of that era, Mariotte originally did not have a deck gun. This highlighted its role as a prototype focused entirely on speed and torpedo attacks rather than surface gunnery. The external Drevesky drop collars allowed the boat to carry and launch torpedoes without taking up valuable space inside the hull. The torpedo sat in a pivoting external frame and was only swung into the firing position right before launch. This setup saved room, but it left the weapons constantly exposed to seawater. As a result, these torpedoes were much less protected compared to the ones kept inside the internal tubes. The boat carried 2 spare sets of reloads for the 4 forward tubes, bringing the total payload to 8 torpedoes. During World War I, it likely used French model 1911 V torpedoes. They had a warhead weighing around 243 pounds and could cover a distance of over 6,562 feet at a speed of 36 knots. Because of this, these weapons were best suited for a close-range deflection attack rather than a prolonged naval engagement. The equipment of the submarine included standard periscopes for observation and submerged navigation. This was critical for carrying out its main mission of escorting the fleet. A wireless telegraph was added later to improve communication during operations. Life support systems relied on supplies of compressed air. This air was used for the emergency blowing of the ballast tanks during diving and surfacing. The system was supplemented by oxygen reserves to sustain the crew during extended submerged patrols, especially when the batteries were running low. As an experimental vessel based on the Emeraude design, Mariotte had the unique features of a prototype. It represented the French Navy's efforts to improve submarine navigation in the open ocean. The crew consisted of 29 officers and enlisted men. This number was optimal for a compact single-hull submarine and its combat missions. The torpedo tubes were built directly into the hull structure to keep its streamlined shape. The designers sacrificed internal space to achieve a high-surfaced speed. Life inside the narrowboat was defined not just by the weapons, but by constant close quarters with the machinery. Diesel engines, electric motors, batteries, compressed air flasks, pumps, torpedo tubes, and crew quarters all had to fit inside a pressure hull that was just over 13 feet wide. Ventilation was absolutely vital after running on the surface, as the diesels produced a massive amount of heat, exhaust gases, and oil vapor. At the same time, running on battery power brought its own risks if the battery cells were damaged or poorly ventilated. The low stern and raised bow superstructure meant that moving along the open deck was only possible in very favorable weather. For the crew, the record-breaking specs of the boat were not just numbers on paper. They were felt through constant noise, vibration, restricted movement, and the continuous monitoring of machinery that often proved to be temperamental. The construction of the French submarine Mariotte was approved by a ministerial order on December 31st, 1906, and the contract went to the naval shipyard in the city of Cherbourg. The keel was laid down on March 30th, 1908 at the Cherbourg Naval Base. The boat was built for open sea operations based on the Mariotte class. It featured a single hull with increased buoyancy in the bow for better seaworthiness. The design emphasized a high surface speed to escort the fleet. Bow, stern, and central ballast tanks were used for diving. Construction of the submarine Mariotte took about 3 years. It was launched on February 2, 1911, marking a significant milestone in the development of the French submarine fleet. Following the launch, the installation of the propulsion system began. The boat received two 4-stroke, 6-cylinder solder-Harl diesel engines producing 700 horsepower each, and two 500 horsepower electric motors for submerged propulsion. At the time of the launch, only the starboard electric motor was ready. The port motor was undergoing repairs, so it was installed later, in early summer 1911. Even after that, constant breakdowns demanded attention and repeatedly disrupted the testing program. Despite these challenges, in August and September, Mariotte successfully passed tests for diving, torpedo deployment, and submerged speed. On December 27, 1911, a serious accident occurred. The air heater of a Model 1909 torpedo exploded inside the torpedo tube. The submarine suffered only minor damage, but this incident demonstrated that the trials involved more than just engine problems. Placing early torpedo systems inside a cramped pressure hull also posed a significant danger. Fitting out took place in the city of Cherbourg. The boat was equipped with four 17.7-inch torpedo tubes and two external Drzewiecki drop collars. Concurrently, mooring trials were conducted to check all systems before heading out to sea. In January 1913, the submarine became fully operational and joined the French Navy. The main diesel engines were delivered with a long delay due to difficulties during factory tests. They were installed from March to July 1912, several years later than planned. Before the equipment was deemed suitable, the oil pan and compressors had to be reworked. Testing of the diesels continued in the fall and early winter, but persistent breakdowns repeatedly halted the process. The Navy had to completely overhaul the entire propulsion system before the boat was accepted into regular service. This precisely explains why so much time elapsed between the launch in early 1911 and the commencement of combat service in 1913. For nearly 2 years, Mariotte functioned as a floating laboratory until its mechanisms became reliable enough to undertake real missions. Evaluation trials for Mariotte began on January 1, 1912. It was an experimental vessel built to test a brand new diesel-electric plant, which was intended to allow submarines to escort the surface fleet. The initial sea trials during 1912 and 1913 revealed serious reliability issues with the 6-cylinder solder-Harley diesels. They frequently broke down, and strong vibrations occurred when running at high speed. This not only created discomfort for the crew, but also threatened the structural integrity of the hull. To address these issues, the French Navy implemented an upgrade in 1913. The engines underwent a major overhaul to improve reliability and reduce breakdowns, while most of the ballast tanks were repositioned forward to the bow. This enhanced the vessel's seakeeping and handling in rough seas. All these modifications were based on test data and aimed at refining the single hull design that originated from the Mariotte-class submarines. Test results came in pretty much as expected. Running on diesels, the submarine achieved a surface speed of 14.26 knots, while on its electric motors, it hit a submerged speed of almost 12 knots. Despite some reliability issues, this prototype played an important role. The experience gained with the diesels and hull stability directly influenced the next experimental French submarines ordered between 1909 and 1912. This boat showed its most impressive performance while submerged. With a submerged speed of nearly 12 knots, the Mariotte was considerably faster than many other submarines of that era, whose submerged speeds typically lagged far behind their surfaced speeds. However, this achievement didn't fully align with the original concept of fleet escort. Battleships and cruisers could maintain higher speeds over extended distances, whereas the diesels on the Mariotte constantly broke down, and its surface range was too limited for prolonged operations with a fleet. This prototype proved that a well-designed hull shape and powerful electric motors could deliver excellent submerged speed. But it also demonstrated that engine reliability, reserve buoyancy, and cruising range were just as critical as setting speed records during sea trials. These lessons proved invaluable, especially since the submarine never went into mass production. When the Mariotte entered service in February 1913, it was assigned to the 2nd Division of the Light Squadron. The boat operated primarily in the English Channel, based out of Calais and Brest. There, it served as a training platform for crews and participated in tactical exercises. Serving in the light submarine forces served as a constant reminder of the dangers inherent in experimental technology and cramped compartments. During an inspection in Brest, led by Rear Admiral Charles Eugene Favereau, a fuel oil galley stove exploded in the bow, causing minor burns to 2 sailors. This incident was minor compared to the engine failures, but it clearly illustrated how even standard equipment could become hazardous inside a small submarine. Later in 1913, the boat was in Calais during a visit by King Christian X of Denmark, adding a brief ceremonial duty to this unusual prototype service. During fleet maneuvers in 1913, the submarine demonstrated the effectiveness of its diesel engines at high speed, proving the design was suitable for fleet escort roles. With the outbreak of World War I in August 1914, the French submarine Mariotte was mobilized into the submarine forces operating in the Mediterranean. It was assigned to the Mediterranean Squadron in Toulon, where it sortied for its initial patrols off the coast of Provence to defend against potential threats from the Central Powers. In July 1915, at the height of the Allied Dardanelles campaign, the Mariotte was transferred to the advanced base at Mudros on the Greek island of Lemnos. Its mission was to support operations in the Dardanelles Strait, specifically by conducting reconnaissance and attempting to break through enemy defenses to cut off Ottoman supply lines into the Sea of Marmara. The Dardanelles mission placed the Mariotte in one of the most heavily defended operating areas for submarines throughout the entire war. Allied submarines attempting to push through to the Sea of Marmara had to navigate narrow waters under the watchful eyes of coastal spotters and searchlights, all while forcing their way through minefields, strong currents, and anti-submarine nets. The French Navy had already suffered significant losses in this area. In January 1915, the submarine Saphir was lost after successfully clearing minefields, but then running aground near Nara. And in May, the submarine Jewel was destroyed. British submariners had proven that a successful breakthrough could seriously threaten Ottoman transport routes on the other side of the strait. Before heading out to sea, Commander Mariotte not only studied the reports of British crews who had already made this transit, but also conducted aerial reconnaissance of the strait. For that time, this was a surprisingly modern attempt to combine aerial reconnaissance data with a submarine operation. On the evening of July 25, 1915, under the command of Auguste Fabre, the submarine Mariotte departed Mudros. She successfully navigated the defensive minefields that had previously sunk the French submarines Saphir on January 15, 1915, and Jewel on May 1, 1915. The following day, July 26th, while operating off Chinook near the narrowest point of the Narrows, Mariotte became tangled in minefield cables. When she surfaced to break free, Turkish shore batteries at Cheminlik opened fire. Shells damaged her conning tower, making it impossible to dive. Fabre ordered the crew to destroy documents and equipment and open the valves to sink the submarine. The crew then signaled their surrender to stop the attack and were taken prisoner by Ottoman forces. Multinational crew members like Morris Wary and Thomas Walsh were held until the end of the war. This incident was the only major wartime action for Mariotte. Her short service was limited by the experimental nature of her design, which had already shown reliability issues before the war. Mariotte had been escorted to the entrance of the strait and rounded Cape Helles on the surface. About an hour later, a searchlight almost gave away her position, forcing the submarine to dive and continue toward the Narrows. She managed to pass under the main mine lines, but near Chinakale, her hull got caught in the cables of an anti-submarine net. The crew desperately tried to free the submarine by surfacing, hoping that moving around on the surface would break them loose. Instead, this put the submarine right in the sights of Ottoman guns at very close range. Artillery hits pierced the conning tower, ruining any chance of diving back down and leaving the crew with no way to escape. Once they signaled surrender and the shore guns stopped firing, the crew used their remaining time to keep their submarine out of enemy hands. They destroyed documents and sensitive equipment and opened the valves so Mariotte would sink instead of being captured intact. Nobody was killed in this final fight, and the survivors became prisoners of war. The wreck settled off Cape Nara in shallow water, about 16 feet deep. Losing her ended a career of just over 2 years. Still, her unique shape, impressive submerged speed, constant mechanical problems, and dramatic sinking made Mariotte one of the most recognizable French experimental submarines of the pre-war era.